Welcome back to the sessions on Matlab basics. So in this lecture, we are going to discuss the visualization part, how to plot figures such as line charts, bar charts, contour charts. In addition, we will also see how to plot three-dimensional figures such as surface plots. So in this lecture, our focus will be on this visualization part, how to draw plots, 2D plots and 3D plots. So from here onwards, we will use these scripts. I have already opened a script, new script I opened. So we'll try to write in this script and we'll try to run these scripts, right? We'll no longer run in this command window. Now let me save it. We can save. Okay, let me write first and then I'll save. So let us plot. Let us start with 2D plots. So as the name itself implies, it requires two arguments, x and y. You need x and y, then we can plot. So Matlab supports a function called plot for plotting x versus y. So but it requires x and y. So let us generate some x and y randomly, then we'll plot. So first we'll generate x randomly. So you can give like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let us say this is x. Let us say y. Let me give the same value as x. Y is x, right? So x is 1, 2, 3, 4, 5, 6, some 10 coordinates. Y is same as x. Now let me plot x versus y, right? Now let me save it. What is this plot? This is 2D plot. 2D. It should not, name should not start with 2, I think, right? Otherwise, let me write plot 1. Plot 1. Okay. Now let me plot. Let me plot. Simply run the script. Can you see the output here? This is the plot. If you want, you can write 0 also here. Then let me run. So now it was a line starting from 0 and then it was going diagonally, right? Because it is x and y are same, right? So this way you can draw these 2D figures. Now let me open one more file. You can simply click here to open new file, right? Now let me generate the data randomly. So initially the plot one, we have taken fixed data. X is fixed, y is fixed. Now let me take random data. How to random means some data will generate between 0 and 100. Let us say 0 and 100. What I am doing is I am generating these numbers with a interval of 5. That means 0, 5, 10, 15, 20 and so on. So how many I have? I have some 21 integers, 0, 5, 10, 20, 10, 15, 20 and so on. Now let me write y equals to x or y equals to x. Let me write y equals to x. Simply write plot x versus y, right? Now let me save it as plot 2. I will show you different types of plots. First we started with this line plot. Now you see, this is the figure between 0 and 100. Now if you want to see what is the output of this command, you can run here in the command window. Now let me see here. Let me show here without this one. Then you will get what exactly this command is giving. You see 0. So this is called step length. This is the ending number. So from 0 to 100, it will generate integers with a spacing of 5. That means 0, 5, 10, 15, 20 and so on. So this is the output of this particular command, right? So this is plot 2. Let me close this figure, close figure. So this is plot 2. Let me bring it down. This is plot 2. This is also line plot, but then the data we have taken between 0 and 100 with spacing of 5 now, right? So now this is simple line chart. So we'll draw some other line charts. Let us say, let me generate some numbers between 0 and 1 with a spacing of 0.01. That means what? It will generate 100 numbers between 0 and 1 with a space of 0.01. That means what? If you want to see what exactly it will return, you paste in the command window and see. It will generate numbers like you see 0, 0.001, 0.01, 0. Like this 0, 0.01, 0.02 and so on. Like this, it will generate 100 numbers. So this I will clear. Right now, so this is the data we have generated. Now let us take y equals to sine of x. So that means what exactly we are doing? I am trying to plot the sine chart, sine graph, x versus y. Now let me save it again. Plot 3. What is this? Okay, no issue. Run. Okay, plot 3 was already there. So they were asking us to rename it. Right? So let me rename. Otherwise, we'll delete this. And let me save it with P4, P3. Why to do all this? P3. So let me run this P3 now. You see here? Command window, you can adjust all these things as I told you. Right? So x, we have some data. Y, what is y? Y is sine of x, right? Y is sine of x, 0 with a gap of 0.01, right? Between 0 and 1, or between 0 and 10 you can generate. This is between 0 and 10. Now let me run this. So plot 3, let me delete this. It was giving some issue with this plot 3. Here is the output. So it was not showing figures. So far it was showing. Let me close it and open otherwise. Matlab.mycodes.com. Let me open. Wait for a minute. So here P3, if I run, yeah, now it was coming. Earlier I closed this figure, that is the issue. Now you see, we have created a sine curve. between 0 and 10, right? So the x values are between 0 and 10 with values 0, 0 0.1, 0 0.2 and so on. And we have applied sine function and we have plotted x versus y. So this is the sine curve that we got, right? Now let us go and create one more function. So let us say x is same as 0, 0 0.01, 10, right? Y is sin x. Now let me plot x versus y only, but while plotting you can add x label, y label, all these things in Matlab. So we can add x label. Let us say x label is x. Let us say y label you can add. Y label is what? Let me add sin x, right? Similarly, you can add something known as title. What is the title of this graph? The title is x versus sin x, let us say. So all these things you can, similarly you can add grids to the figure. You can add grids to your figure. So this can be done by using a command called grid on. So all these things you can add. Grid is on, right? Now let me save this with the name P4. P4. Now let me run this one. Invalid expression. Where is this? P4, line 3. X versus sin x, grid on. Plot x comma y. Right? Missing unbalanced delimiters. It was giving some error. What is the error? Plot xy. So error is not here. Error is here. Maybe let me see. Error go here. The error is here. It should be column, right? That is the issue. So now let me run this one. Here I should add comma. You see now, you see invalid expression still. X versus y. First let me delete this one. First let me run this one. We got this one. We got the output. Same output, I think, right? Well, let me show this one. Yeah, this is this one. So when I run this one, we got an output like this, right? Now let me add one thing. One by one we'll go because it is giving some error. X label. Let me give x. Let me run this one. Yeah, now you see we got the x label x here, right? Similarly, you can add y label. What is y label? Y label, let me give sin x. You can run this script. You will get this, you see. This is your sin x. Similarly, let me add title. Title of the figure. X versus sin x. You see, title was also added, x versus sin x. Now, similarly, let me add the grids. It can be added using this option, grid on. You see, grids were added. Can you see the grids were added here? Right? Grids were added. So this way you can add different options. X label you can add Y label, title, grids, everything you can add. So this is about these line charts. Now we'll move on to the next type of charts called bar charts, and then we'll show the contour charts. So before moving on to the other type of charts, let me show you how to draw multiple charts, means multiple figures in the same plot, right? So this, let me use the same thing again, same data, 0 with a step length of 0.1, 0 and 10 I am taking values. Let me take y1. y1 is, I apply sine function on x. Then y2. y2 I apply cos function on x. And I want to plot both the figures in the same plot. Now how to plot both the figures? Suppose if I write plot x versus y1 and then plot x versus y2. Now we'll see what happens when you write two commands. Right, this is P5. Right, let me plot this one. So the result is only one plot. We have plotted both sine and cos, but it was only showing cos. Now what happens if I write again one more plot, y1? What happens? You see what happens? What happened? So that means it implies the last plot, the last command is the one which is staying. So that means this plot was overwritten by this command and this plot was overwritten by this command. So therefore, writing these individual commands will not work. Now how to draw multiple plots? How to include multiple charts in the same plot? So this can be done like this: x versus y1, write x versus y2. You can write everything here, x versus y1 and x versus y2. Let me plot this one now. Now you see, can you see? Two charts are coming. One is sine, the other one is cos, right? Now this is sine and cos. We were able to differentiate between these two. But if suppose you don't know what is this blue, what is this orange, then you can add something known as legend. So what is this legend? In the same order you give. What is the first one? First one is sin x, right? And then similarly the second one is cos x. This way you can give, and let me run now. Now it will clearly differentiate what is what. So the blue line, blue figure is sine figure, sine curve, and the orange curve is cos curve, right? I hope you are able to differentiate now due to this legend, right? So this way you can add multiple charts in the same figure. Now if you see the color of these curves, by default it was giving blue and orange. Now suppose you want to change the color of these lines. By default it is giving some color. Now you want to change the color of these lines. Can you change the color of these lines? Yes, you can change. How to change? Suppose you want to give the first curve, I want to give some red color. So you give R. R stands for red. Second one, I want to give, let us say green. I want to change from both, right? I want to give red and green. You simply give the color codes and then simply run it. What happened? X. Oh, here one was missing. Let me add and let me run. Now you see, it was green, it was red. So sine curve was with red, cos curve was with green, right? So there are some predefined colors which can be used, like RGB, primary colors, you know, red, green, blue, CMY, right? Magenta, yellow, cyan, right? Similarly, white you can use, W stands for white. And similarly, you can use all other codes, but these are the shortcut characters for these colors, right? So now, okay, so we have seen how to create multiple charts in a single plot. Now we will move on and we will see something known as subplot. What is this subplot? So let me show you again the idea of subplot. It is simple, very simple. 0, 0.01 and 10. This is the data. 0, 0.1, 10. Then y equals to x, not x. Y equals to sin x. So let me call it as y1 otherwise. y1 is sin x. y2 is cos x. Now, instead of drawing both the charts in the same figure means same plot, I want separate plots for sin and cos, but I want both of them to be in the same figure. That means what? The figure and plot, the difference is like this. So we'll have a single figure with this border and everything. This is your figure area. This figure area will be divided into two plots. So here your sine curve will come. Here your cos will come here. Your cos figure will come here and sine figure will come here. These are called subplots. So entire plot area was divided into two subplots. This is first subplot. This is second subplot. Right? So similarly, you can divide your plot area into different ways. Let us say you want to divide your plot area into 4 figures, then divide into 2 rows and 2 columns. This is your first plot, second plot, third plot, fourth plot. So that means this is first row, first column, this is first row, second column, second row, first column, second row, second column. So this can be done using this idea of subplot. Now we'll see this idea of subplots now. Right? Now how to draw these subplots? It is very simple. You use a command called subplot and write 1, 2, 1. So that means what? This means your area was divided into 1 row, 2 columns. 1 row, 2 column means what? Let me write here itself. 1 row, 2 column means this is your area. 2 columns, that's all. This is first figure, this is second figure. I hope you understood. If you are dividing it into 3 rows, 3 columns means like this. It will be divided into 3 rows, 3 columns. We have divided into 1 row, 2 columns. And then this is the first figure. First figure I am plotting. 1, 2. That means 1 row, 2 columns total. So this is your first figure. So what is your first figure? Now call the command plot x versus y1, x versus y1. Now the other plot, subplot 2. What is the other subplot? 1, 2, 2, second figure. What is this plot? This should be x versus y2, right? So let me save it. What is this? Let me call it as P6. Now let me clear all this, some errors are there. Now let me run this one. Can you see now? The plot area was divided into 2 subplots. This is first subplot, sine. This is second subplot. Right? Here again, you can add all kind of things. If you want to add color, you add color. Right? If you want to add, let us call it as blue. You can add colors, you can add X labels, Y labels, all these things you can add. So that means if you want to add X label here, right? For this plot, what is the X label? X label is, let us say X. Or you can write sin X. Let me directly write sin X here. And for this, suppose your X label should be cos X. You can write directly cos X. You can add all these things, X labels, Y labels for individual subplots. Right? You can add y label also. So this is about line charts. So let me close some plots, which are very basic plots. These are right. Now we'll move on to other new script. I'll open new script. So now we'll move on to the other kind of plot. So we'll see bar plot now, bar chart. So this bar chart also very simple, right? So bar chart we'll see now. So this bar chart, idea of bar chart is also very simple. So bar chart means what? I hope you know this bar chart. Bar chart will be like this, right? This is one bar, this is other 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 bar, like this. This is bar, right? For different values, what is the, like it is like histogram. You can say that it is the histogram. That is the frequency of each frequency of something at each value. So let me generate this bar chart. This is also very simple. Let me generate some data. Let us say 1, 2, 3, 4, and so on. Right? Let me simply write 1 to 10. So if you give like this 1 to 10, it will generate integers in the range 1 to 10 with step length 1. So the default step length is 1. You can see this output of this command. So it will generate integers from 1 to 10 with a step length of 1. You see. If you want to generate integers with step length 2, you give here 2. This is numbers between 1 to 10 with step length 2. Is it clear? So this is a x. Now let us say y. Y, let us say I want to generate how many? 10. Right? I want to generate the bar chart like increasing order. So let me generate what I do. I will start with 1. I will go up to 10, 100, right, with step length of 10. So that means the counts will increase. Now you want to draw a bar chart. Bar chart, it is very simple. The command is bar x comma y. That's all. Simply run this command. Okay, let me save it. T8. T8. Let me run this one. Yeah, you got, you see, these are the x values, these are the frequencies. You see, the frequencies are increasing because the values in y were 110, 110 and so on, 111, 21 and so on, right? So therefore, these are the frequencies. You see, this is a bar chart, right? So this is the other kind of chart. Similarly, there are many other charts. Now let us say, before going into this 3D charts, now let me present one more thing called contour plot. What is this contour plot? Suppose you have some 3D plot. You have a 3D plot. Now you want to display the 3D plot in 2D space. You want to display the 3D plot in 2D space. Then this contour plot will be very useful, right? Let us say the contour plot. Let us consider this contour plot now. So P9 is for contour plot. So let me generate some data x versus y, right? So x, let us call x the numbers from -5 to +5 with a step length of 0.1. Okay, and y is from -3 to 3 with a step length of 0.1. Okay, so this is x and y. Now, in order to generate this contour plot, let me wait for one moment. Yeah, all right. So this contour plot, what we have? We have 3D data, right? But we want to display on 2D space. Now this contour plot, we have x and y, right? What is x? X runs from -5 to +5. What is y? Y runs from -3 to 3. Now these are x and y. Now if you generate something on x and y, let us say x square plus y square, what you will get? You will get 2D. But what do you want? You want it 3D. Although you are displaying on 2D, that is different. But you want to have something called, let us say, x square plus y square, right? And you want to display the contours. So let us use some function called mesh grid. So this mesh grid will convert this independent variables into in 2D. You will get the coordinates in 2D you will get. So that means these are independent now, x and y, they are independent. Now you have some function called mesh grid. So if you apply this mesh grid, then what you will get is, you will get these coordinates, -5, -3, -5 and so on. All these coordinates, 2D coordinates you will get. So it will return 2D coordinates. So at every point you will get 2D coordinates. So now here we have only 1D. Now let us convert into 2D. How to convert into 2D? We have a function called mesh grid. To this mesh grid, you supply x and y, right? So let me directly pass these values instead of supplying these things. This is x, right? And then let me give y also. What is y? This is y. This is my y. So x and y I have supplied to this mesh grid function. So then it will give the 2D coordinates now. 2D coordinates as x1 and y1. Now if you want to see what exactly this will give, you can see here what exactly the output of this mesh grid command. Okay, let me remove this semicolon, then you will understand. You see, these are the coordinates. You see, this is x, this is y. X and y both were there. Okay, this is very big. So let me write 1 here with step length 1, then you will understand at least. Oh, not here. It should be here. So let me remove this. Now let us see here what it will generate one by one. It is very simple, you see. These are the values, right? Mesh grid, answer. Right? Now we got this x1 and y1. Now we will generate a contour plot. So for this, let me apply a function. Let us say x square plus y square. So you can simply apply this like x square, right? X square plus y square. X square plus y square. Now let us draw a contour plot. Contour plot between x1, y1 and the value g. Now let us save this as P9. Right? Let me run it. Some error. What is this? X square plus y square. Let me remove it first. Let me see what is the issue. It should not be the case because we want element wise I want, so it should be dot. It is element wise power, right? Otherwise let me fix everything same. minus 5 to 5, minus 5 to 5. It should not be the case. It should work like this also. I don't know. Right? Still there is an issue. Okay, this contour, I don't know why this contour was not working. Actually, it was supposed to work. Right? What is this? Oh, this should be x1 and y1. Yeah, that's why x1 and y1. That's why. Now you can keep 3 and 3. That is the issue. So this, the result of mesh grid you have to use for this function. So this dot indicates that you are applying element by element. So that means every element of x and y you are applying this x square plus y square. So you are getting a function. Now that function you are plotting, you see. So this is the contour plot. Can you see here the right hand side we got a contour plot, right? So finally I will show something known as surface plot. So what is this surface plot? Again same. Let me first apply a mesh grid function for some x and y coordinates. Mesh grid, let us say minus 5 with a step length of 0.1 and between minus 5 and 5. Similarly minus 3 and 3 with a step length of 0.1 again. So I applied mesh grid function. Now you apply a function. Let us say instead of x square plus y square, you apply e power minus x square plus y square. So e power x square plus y square. But it should be applied on every element. So I use the dot. So dot means the same thing will be applied on each element of this x and y, each coordinate, each xy coordinate. We apply this exponent, right? Minus x square plus minus y square, let us say, which is nothing but e power minus x square plus y square. Let me multiply with some x also, otherwise. This is also again element wise multiplication, right? Now let us plot surface plot. The command is very simple, surf x, y and g. So let me again save this one, P10. Surface plot. You see here, you got a surface plot here, right? If you want with more clarity, let me change the values, then you will get with more clarity, right? So let me use minus 2 to 0.2 plus 2. Minus 2 to 0.2 mesh grid, right? Let me run it now. X times exponent of minus x square plus minus y square. This is not the exact surface plot I was supposed to see. There is some issue. It is a issue mesh grid minus 2, 0.2 plus 2 plus 2. I have not written plus 2. Done. Yeah, can you see the surface plot? This is a 3-dimensional plot, you see, right? This is called surface plot. I hope you know this surface plot. So using the surf command, you will get this between x, y and the value. G means what? This is the z dimension, the dimension z, right? So I don't know how many of you understood this mesh grid, the idea of this mesh grid command. So you see, this is 1D code, 1D. This is 1D. Right? Now you are generating a function. Let me write here. Only let me spend some time on this mesh grid command. So let us say you have 1D. you have 1D coordinates, right? Some coordinates. Similarly, you have 1D coordinates on y axis. Now, in order to make it three-dimensional, let us say x square plus y square is the function. You want to show it on z axis. Now you have to give x and y, right? Now this is separate, this is independent, this is independent. Now when you generate coordinates, let us say this is one coordinate, this is other coordinate, this is other coordinate, other coordinate, other coordinate, other coordinate, and this way if you let us say, let me draw lines at these points. How many coordinates you will get? You will get all these coordinates, 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 and all these coordinates. That means all possible x and y combinations. This is one coordinate, this is other coordinate. So these are all possible x and y coordinates, right? So we should get these all possible x and y coordinates. So these coordinates we give as input to this function. Let us say this is g equals to x square plus y square. So this function will be applied on each and every, this function will be applied on each and every, yeah. So now you have to supply these coordinates to this function. This function will be applied at each and every coordinate. Let us say this coordinate you take 1 1. So the function you will calculate the value of g at 1 1. Similarly, you will calculate the value of g at 1 2, 1 3, and so on. So this function has to be applied at every element. Now how to get all these coordinates? One way is you manually do. Take first element of x and every element of y. Second element of x and every element of y. All possible combinations. But if the length of x and y are very large, if you are doing it manually, it may not be a better approach. So that's why the designers of Matlab, they have given this option of mesh grid. So this mesh grid, what it will do? So these are the independent x coordinates. These are the independent y coordinates. Now what are the possible x and y coordinates? It will return. This mesh grid will return all possible x and y coordinates. Right? Here you can see what is there in x1 and what is there in y1. You see what is there in x1 and what is there in y1. So let me open x1. What is there in x1 you see. So this is the value in x1. Similarly, what is there in y1? You can see what is there in x and what is there in y. X and y contains, you see x and